All right, let's look at the mathematical induction proof for the following statement. Right, it goes like this. For all natural numbers n, complement of the intersection of set a1 through an is equal to the union of the complement of a1 through complement of an. Right? So this is essentially the extension of De Morgan's law, which states complement of intersection of two set is equal to the union of the complements of those two sets. All right, so let's try to prove this statement by induction. All right, let's start with base case. All right, base case, we're going to try to establish that the statement is true for n equals 1. Right? So if you look at the left-hand side, when n equals 1, you only have one set, so it's going to be a complement of a1. So we have that. Then right-hand side is actually exactly the same, so you have a complement of a1. So therefore, left-hand side matches the right-hand side. All right, so that was pretty simple. And then next step would be the induction hypothesis. All right, so this is simply an assumption that the statement is true for n equals k. So we have this equality. All right, so this is just an assumption. There's nothing to justify. All right, so here is the main step, which is called the induction step. So we are trying to establish that the statement is true for n equals k plus 1. So this is what we want to establish. All right, so let's start with the left-hand side to see if we can get to the right-hand side. So here is the chain of equality. All right, so we're going to have to start with the left-hand side. All right, so first step is I'm going to group the first k sets together. So we put the parentheses there, right? So that we can apply De Morgan's law. So you can think of this chunk to be A and then this to be B. So complement of the intersection of two set is going to be a union of complement of those two set. So this is by De Morgan's law, so I put a little color coding here, right? So to get that. Then you realize that this first set is actually the left-hand side of the induction hypothesis. So I'm going to replace it with its right-hand side. So that's why we have here. And again, I color-coded it. All right, then you have a union with the complement of ak plus 1, right? But you can see that this is exactly the same thing as the right-hand side, right? So therefore, by mathematical induction, this statement is true for all natural numbers n. All right, that's it. I hope that this was clear.